All right, so this is the last one we're going to do, and we're just writing out the general form of the partial fraction decomposition. We're not going to find the coefficients. And if you look at this guy, it should be pretty clear to you that this is going to be a beast. So we definitely don't want to have to find coefficients here. But we do first need to factor. Most of our terms are factored out, but there's this sneaky guy on the bottom here that isn't. So we need to start by factoring and grouping like terms. So this is x to the 14th over x to the 4th plus 1 times x squared plus 1 squared times x plus 1. Whew. And now when we simplify that, we'll get x to the 14th over x to the 4th plus 1 times x cubed times x squared plus 1 squared times x plus 1. All right, so next we need to consider the degree of the numerator and denominator. The degree of the numerator isn't hard to figure out, it's 14. But the degree of the denominator takes a little bit more work. We have a degree 4 polynomial times a degree 3 polynomial. So we're at degree 7. And then we have a degree 2 polynomial squared, and that gives us a degree 4 polynomial. So we're at 11, and then times another degree 1 polynomial. So we have degree 12 in the denominator. So we need to long divide, but of course we don't want to long divide. This is going to be hideous, right? We don't want to multiply out that denominator. But if we did long divide, what would we get? We'd get a quadratic. We'd get a degree 2 polynomial because 14 minus 12 is equal to 2. So we're going to start with a x squared plus b x plus c, right? The general form of a quadratic. And then we'll go ahead and start adding our fractions in. So that first term is a irreducible quartic. So in the numerator, we're going to have to end up with a degree 3 polynomial. So we'll write dx cubed plus ex squared plus fx plus g over x to the 4th plus 1. And now that x cubed term, it's raised to the 3rd, so its multiplicity is 3. So we'll end up with h over x plus I over x squared plus j over x cubed. All right. Now this x squared plus 1 term, it again is a degree 2 polynomial. So we're going to need a degree 1 polynomial on top, kx plus l over x squared plus 1. But then it's squared, so we'll have to add mx plus n over x squared plus 1. And then I'm going to skip O because it looks like a 0. P over x plus 1, that last term. So this whole thing is the general form of your partial fraction decomposition.